Everyone is obsessed with dinosaurs. And honestly, fair enough. T-Rex, Velociraptor, Triceratops, they earned their reputation. But here is something paleontologists do not say loudly enough. Dinosaurs were not even close to the scariest things that ever lived on this planet. Not even close. The animals in this video existed before dinosaurs, alongside dinosaurs, and in some cases long after dinosaurs were gone, and every single one of them makes a T-Rex look like a reasonable neighbor. This is not myth, this is not science fiction. This is the actual history of life on Earth, and it is genuinely terrifying. We go back first, way back, 430 million years ago. Before the first tree existed, before the first reptile, before anything with a backbone had crawled onto land, the oceans of Earth were ruled by something called Jaekelopterus rhenaniae, a sea scorpion. That description alone should give you pause, but the size is what makes this real. Jaekelopterus reached lengths of approximately 2.5 meters, 8 feet long. A scorpion, 8 feet long, swimming through the ocean. We know this not from imagination, but from a fossilized claw discovered in Germany in 2007. That single claw measured 46 centimeters larger than any claw of any known arthropod in Earth's history. Paleontologists used that claw to estimate the full body length, 8 feet. It had compound eyes, a hardened exoskeleton, powerful grasping claws at the front, a spiked tail. It was an apex predator of its era, hunting fish, other arthropods, and anything else that moved through those ancient seas. And here is what I want you to sit with for a moment. This thing was real, not a concept, not a rendering, a real animal that swam in real water, that hunted real prey for millions of years, before a single dinosaur existed, still in the ancient ocean. Around 360 million years ago, the Devonian period, sometimes called the Age of Fish because fish were diversifying explosively, filling every ecological role available. But one fish was different, Dunkleosteus turelli. It reached approximately 9 meters in length, roughly the size of a large great white shark. But its defining feature was not its size, it was its jaws. Dunkleosteus had no teeth. Instead, its jaw bones were sharpened into blade-like edges, essentially self-sharpening bone blades that worked like scissors. Researchers at the University of Chicago calculated its bite force using biomechanical modeling. The result: approximately 7,400 pounds of force per square inch at the tip of the jaw. For comparison, a great white shark produces roughly 4,000 pounds per square inch. Dunkleosteus nearly doubled that, and it could open and close those jaws in approximately 50 milliseconds. 1/20th of a second, fast enough that the rapid opening created a suction force pulling prey into the mouth before it could react. It did not chase its food. Its food came to it, involuntarily. Fossils of other armored fish have been found with Dunkleosteus bite marks punctured, sliced, and in some cases folded in half, by a jaw that moved in 50 milliseconds. There was no surviving an encounter with Dunkleosteus. There was only the encounter, and then the aftermath. You have heard of Megalodon, but I promise what you have heard is not the full picture. Ototus Megalodon lived from approximately 23 million to 3.6 million years ago. Conservative estimates place its length at 15 to 18 meters. Some specimens suggest up to 20 meters. Its teeth, which are the primary fossils we have, reach up to 18 centimeters in height. A great white shark tooth averages around 5 centimeters. Megalodon's teeth were more than 3 times larger. But here is the detail that changes how you picture this animal. Megalodon did not hunt fish. Its primary prey was whales, large whales. Fossil evidence whale bones with Megalodon bite marks shows a specific hunting pattern. Megalodon targeted the fins, flippers, and tails first, not the body, not the head, the mobility. It disabled the whale's ability to swim, then return to feed at its own pace. That is not instinct alone, that is strategy. A predator that systematically removed its prey's ability to escape before killing it. Whale bones with healed Megalodon bite marks have also been found, meaning some whales survived initial attacks. They escaped, they healed, and they carried the scars of Megalodon for the rest of their lives. Megalodon went extinct approximately 3.6 million years ago. The leading hypothesis: the oceans cooled, whale prey migrated to colder waters where Megalodon's physiology could not follow, and the food supply collapsed. It did not die because something beat it. It died because its food moved somewhere it could not follow. That distinction matters. Nothing defeated Megalodon. The climate changed. You think you know what a crocodile is. You do not know what a crocodile can be. Purussaurus brasiliensis, 8 to 11 meters long, approximately 5 to 8 metric tons. It lived in South America during the Miocene epoch roughly 8 million years ago in what is now the Amazon basin. At that time, the Amazon was not a river. It was a vast inland sea, a massive wetland system covering millions of square kilometers, and Purussaurus was its absolute ruler. Its skull alone measured around 1.5 meters in length. Using biomechanical modeling, researchers calculated its bite force at approximately 69,000 newtons. That number requires context. A modern saltwater crocodile, the largest living reptile, produces approximately 16,000 newtons. Purussaurus produced more than 4 times that force. It could bite through bone the way you bite through soft bread. It was not selective about what it ate. Fossil evidence suggests it consumed giant rodents, large turtles, primitive horses, and early relatives of modern cattle that came to the water's edge to drink. It did not ambush prey. At its size, it did not need to. It simply approached, and nothing left. Purussaurus was not the ancestor of modern crocodiles. It was a separate experiment, an extreme version of the crocodile design taken as far as physics and biology would allow. And for several million years in that vast inland sea, nothing challenged it. Nothing even tried. 66 million years ago, the asteroid hit. The non-avian dinosaurs were gone within geological moments. The world was devastated. And then, into that emptiness, something moved. Titanoboa cerrigonensis, discovered in 2009 in the Cerrigon coal mine in Colombia, the largest snake ever found, 13 meters long, roughly 135 kilograms. To understand that size physically, its body at its widest point was approximately 1 meter in diameter. 1 meter. You could not wrap your arms around the midsection of this animal. Titanoboa lived approximately 58 to 60 million years ago, in the earliest period after the dinosaur extinction. With the giant predators gone, it filled the vacuum. It lived in tropical swamps and rivers hunting large prey, including giant turtles and primitive crocodilians. It was not venomous. It did not need to be. At 135 kilograms, it killed through constriction, a method that does not simply suffocate prey as commonly described. Research published in the Journal of Experimental Biology clarified what constriction actually does. It stops blood circulation. The pressure applied by a large constrictor is enough to prevent the heart from beating. Prey loses consciousness within seconds, not minutes. Titanoboa applied that force with over 1,000 kilograms of muscle. Nothing survived. But there is a detail about Titanoboa that paleontologists find as interesting as its size. Its existence tells us something about the ancient climate. Snakes are ectothermic, cold-blooded. Their maximum body size is constrained by ambient temperature. A larger body requires a warmer environment to maintain function. The size of Titanoboa tells us that the average temperature in that ancient Colombian rainforest was approximately 30 to 34 degrees Celsius, significantly warmer than the same region today. A fossil snake, that tells us the temperature of a rainforest 60 million years ago. Paleontology is extraordinary in ways most people never appreciate. Here is what all of these animals have in common. None of them were accidents. None of them were mistakes. Every single one was a perfect solution to a specific environment at a specific moment in Earth's history. Jaekelopterus ruled ancient oceans before fish had even diversified. Dunkleosteus dominated the Devonian with jaws that operated faster than the human eye can follow. Megalodon hunted whales strategically for 20 million years. Purussaurus held an entire inland sea as its private territory. Titanoboa inherited a world still recovering from catastrophe and became its apex predator within a few million years of the dinosaurs vanishing. These animals existed, on this planet, in real ecosystems, with real prey, and real dominance that lasted not for decades but for millions of years each. The dinosaurs get the movies and the museum exhibits, but the full history of life on Earth is far stranger, far more extreme, and far more humbling than any single era. We live on a planet with a 4 billion year history of life, and we have barely scratched the surface of understanding it. If that kind of thinking, the real history, the documented science, the things stranger than fiction, if that is what you are here for, then you are in the right place. Subscribe, because there is so much more of this, and we are just getting started.